What do we actually do as a software engineer? Especially now with AI tooling, I feel that there's a lot of misconceptions or just general lack of info on what we do as a software engineer. And that's what this video is for. We're going to be talking about questions like, do we actually spend all day coding? Do we spend all day working on leak code questions? Are we just facing our computers and never talking to anyone? And is ChatGPT or Claude just doing our whole job for us? And at the end, you'll know all the responsibilities that we do on the day-to-day. Now, before we get into it, make sure to like, subscribe, and comment below what do you think is the coolest part of the job. Now let's start talking about some responsibilities. Now, for reference, I'm a software engineer for a minute. I've been working at different companies from big tech to startups and stuff in between. And I mainly worked on what's called product growth teams. And you can think of product growth teams as a company trying to invest in new products to get new customers. Product growth team works on creating the product and handling any end user requests or new features. I think the biggest thing I do on the day-to-day is some kind of system design. Whether that's working on a new product that's being built out or making changes to existing products. I think that the biggest thing is some kind of review and change to some product. Sometimes this means, a code change here or there, but a lot of times this can also mean just no coding whatsoever, just diagramming and document writing. Sometimes, I'm going to be honest, I can go for even a month without touching a single piece of code other than reviewing and not really needing to write any new code. This is because of how many moving pieces there are in what's considered system design at a big tech company. And system design, if you don't know it, is taking a product idea and scoping it down to the specific components and individual details that would be used by us programmers to build out the actual final product. Where you can't just take an idea and work right away with it into code when there's so many parts, so many things that can be impacted. So there's a whole process to go through it. This requires, a lot of designing and a lot of document writing. This is all brought up in what's called a functional spec, where a functional spec just aggregates all these details together and lets us, the programmers, know what we are going to be building. We answer questions in here like, what technologies are we using? What does the database look like? If we're using any routes, we're building a REST API, what will those routes look like? And usually this process works with a product manager, at least on the teams I've been on, where they're kind of the middleman between you, the engineers, and the end users, the customers. They focus on what is the product that we are actually building, and you can think of the engineers as working on how we are going to build it. In my opinion, this is a very interesting part of the product because you end up being able to potentially impact the final product itself. And usually during this part, you're not going to just speak with the rest of your team. You're also going to probably need to speak to other engineers and other teams. Like if the product requires you to work with some other existing tooling at the company, you're probably going to need to speak with them to see how you can onboard onto it and if there's any risk or limitations in using their service. If it's a customer facing product, you're probably going to need to speak with designers or, depending on the structure, maybe the front end engineers to see how your back-end system is going to communicate and interact with their front end, which is how the end users will see it. This is super important and useful because you'll need to know, if you're making API routes, how will those routes be used? And that will help you know how to actually design it and what data to actually bring up in them. During this part, you may also do some research and create a little POC. I feel like now with AI, this is actually one of the most useful parts of it, where you're actually able to spin up a very quick and dirty version of the end user product where you can test specific functionalities. Like if I'm using AWS, for example, and I've never touched it before, I may be able to create a little project that uses lambdas and speaks with SQS to then insert into, some database somewhere. And all these details and everything from these conversations that gets brought up, they are going to be left in this functional spec somewhere. A lot of times it's maybe writing, but it can also end up in diagrams. And when it comes to actually finishing it, it's a very iterative process because you'll need to get buy-in from the team and see if there's any things that you missed or if there's anything you can change to improve. And based on that, you make those changes and then you go back to get another review from the team. And so it's a very iterative back and forth process with them. This is very different from what I thought software engineering was going to be, where I'm spending most of the day actually talking to a lot of other teams, thinking of theoreticals and writing a bunch of interesting findings and thoughts on how to solve this puzzle of what are we going to actually build. I think that this is honestly the most fun part of the job, being able to take this idea and scope it into something that's specifically like workable by people and something that you're able to see when you're writing the code as like, this is what I'm focusing on building right now. Funnily enough, though, I would say this is where a large part of the misconception lies in what we do as software engineers, just because, you know, when you're going through uni, you're learning computer science, which is something completely different, or you're studying for interviews, which is usually leak code. Sometimes you may hear system design interviews, but usually for beginners, it is usually just leak code. And that is completely different from what we do. In my opinion, this is a side rant. I think leak code is a terrible way to do interviews. And I think that is so different from what we actually do in the job that it's crazy to think that it's a good way to prepare for interviews is to study like crazy just for the interview and then be okay with forgetting everything because it's completely different from what you do in the job. I'm getting ahead of myself here, but yeah, on the job, you can expect problems to be more products or, you know, holistic on a system of how this component communicates with this component, completely different from leak code, which are usually just like individually scoped data structure and algorithms, usually some puzzle easily solvable given enough time. The closest thing are probably personal projects where, you know, you're working on building something up from scratch. I would say that's probably the closest to what we do on the day-to-day on average. But rant aside, going back onto the topic here, once you finish the system design, you're going to work on the actual implementation. So when you're writing the actual code, there's a lot of ways we like break it down so that it's easily workable by multiple people at the same time. There's at the highest level, there's usually the stack. So there's usually a differentiation between front end and back end, where the front end works on all the UI and everything that the end user actually sees and interacts with. Like if I'm working on a YouTube or Twitch clone, it would be like the video panel that you see, the comment bar, the like button, the subscribe button, everything that you see there on that website. That is what a front-end team like designs and builds out. This is usually like HTML, CSS, some JavaScript or JSX that handles all these interactions. It's like how the screen looks, how the colors are, what happens when you click specific buttons. All those interactions are front-end. And the front-end speaks to the back-end in a bunch of different ways. Usually the most common way though is with API requests. The back-end handles everything that goes on behind the scenes. It handles all the server logic. So front end speaks to back end, usually by API requests. You can think of the back end's responsibility as everything from making those initial API contracts down. Going back to this YouTube example, on the back end, if somebody likes and comments on a video, that information gets sent to us, and then we handle the actual data operations to change the state. And so that if I refresh the page, I can see that information updated and shown there. Things like rate limits, authentication, permissions, data manipulation, that's all us on the back end having to handle this and serve it to the front end in some way. You may need to update the database with some migration where you may add or modify a table, or you may add some new fields or indexes that are going to be used. There's also infrastructure, which sometimes gets done by a DevOps team, but a lot of times it can also be done by, you know, the front end or the back end engineers. You can think of infrastructure as just what you need to actually run your code. Like for example, I may need a database, I may need a queue, and I may need some place to run my REST API. And on the front end, I may need something to actually host my website. These are all pieces of infrastructure that you have to stand up and maintain. Now, I'm probably gonna go on another side rant here, but another question people probably have is, how do we actually write code, or do we even write code nowadays, now that there's a lot of AI tools out there for, you know, writing code? In my opinion, in my experience, well, there is a lot of use from a lot of these tools. At the end of the day, we still need to know what is actually being generated, and in a lot of cases, like still modify it or handwrite it ourselves. This is because a lot of these tools are super good for like well-defined, small-scale stuff, but when you start dealing with, you know, larger scale systems that where one change could impact a change in another completely different like component or another different repository you're working in, it starts to not be as good at keeping track of, you know, potential bugs you are trying to avoid. So yes, we still do use it a lot. Like I'm a big fan of some of these tools, but it's important to know that there's a lot of limitations with where they're at currently. And so you still need to know what you're writing, and you still in a lot of cases need to write it yourself. Now, aside from working on new product features, we also have to work on maintaining, you know, existing products, making sure everything is working 100% all the time. This comes in two ways. One way is just, you know, we get new product features and we have to work on implementing them into like our existing product. Sometimes it's easy. We're able to just scope it down into something simple that is easy to implement. Other times we have to go to the drawing board and make up a whole design document on how to do this addition to like the existing product. But that's usually rare, and these features are usually pretty well defined. The other way is through something called on-call. So you can think of on-call as like every X couple weeks, usually you're the one on call as an engineer. And if there's any bugs that occur at any point in time, you're the like go-to person for it. So you're in charge of like if at 3 a.m. some bug happens and the whole system shuts down, you're going to get paged and you have to wake up and go onto your computer and figure out what's going on here. Yeah, it's not as fun as it sounds. It kind of sucks, honestly. I think most engineers would agree. It usually happens pretty rarely, and a lot of the times it's for things that are, well known by the team. So there's usually a lot of processes that you can follow to try and debug it and figure out what's going on. Like we may define what's called a run book, where if certain issues happen, certain bugs are found, you can follow these steps to usually diagnose it and then potentially fix it. And for everything I've mentioned so far, don't expect to work on it alone. Expect to have a bunch of meetings about it. A lot of teams usually follow what's called agile, where there's like a set structure to how you get work done. And because of that, there's usually like a good amount of meetings just to keep everybody updated with it. This usually occurs over a 2-week period that we call a sprint. And within the sprint, there's a lot of stories, which are just like individual pieces of work that you can do to complete like a certain task. And you can expect what's called stand-ups to just keep everybody on the team updated on where you are in the sprint, what stories are you working on, do you need any help with anything, things like that. This depends on the team. Sometimes it's every day, sometimes it's every few days, sometimes it's once a week even. And if you're working on like a system design, expect meetings, like I said, to get it reviewed, and to get it reviewed not just by the team, but potentially like any dependencies you may have. Like if you're using some other team service, you may want to get buy-in from them. When it comes to the amount of meetings you're given, there's no one set answer. It depends on the team, not even the company, just the team itself. Some places may have a lot of meetings for the team. Some places may have very few. In my opinion, if you can try and find a team that has a few meetings, it's usually pretty good, because that means you're, spending more time working on the actual product itself than having meetings about it. And there you have it. That covers the average work experience of a software engineer, what we have to do on the day-to-day. I hope this gave a good idea of what we do on the day. If you have any questions, make sure to leave it below. Peace.